So this is part 2. I was about to go on to the next question, which involves deriving the equation of a circle. And what I'm really coming up with is something pretty much equivalent to, I'm trying to find a piece of paper to write on here to show you what I'm about to present here. Something equivalent to, of course I can't find a blank sheet of paper. Give me one sec. I'm writing something down here for you. You're going to love it. And don't make fun of my m. Something equivalent to y equals mx plus b. You can graph any line. From algebra 1, you can graph any line if you have the y-intercept and you have the slope. Well, you can also graph any circle with 2 pieces of information. Now, you think about y-intercept, yeah, that might show up in the equation. You think about slope. A circle doesn't really have slope because the slope's always changing. As you go around the circle, there's not really a slope. Not for the whole thing. There are 2 things that you can use to describe a circle, though. And you kind of just discovered one of them on this previous one. I asked the question in both classes, if it's equidistant, tell me what that distance is. Then they're equidistant from the origin. How far is every single one of these points from the origin? Just look at the graph to figure that out. And most people figured out that, well, it's 5 units away. This one's 5, that one's 5, and all these ones that are on the diagonal, they're still 5 units away because I can just rotate this. And of course, you can see what I'm rotating. What is this distance really called? What is the distance that's across here from the center to the edge? Well, that's called the radius. So we're going to use the distance formula, which you just did a couple minutes ago, or maybe did on Friday. We're going to use the distance formula to come up with something like this. I don't know if you can see y equals mx plus b for circles. It's not going to be m and b. They're going to be different variables. So let's go for it. So first thing, I gave you a dot on your graph over here. That dot was supposed to be the center of a circle. So just sketch a circle. I don't care how big or small it is. Don't make it too small. And give you some new information perhaps here. We already said every point on a circle should be equidistant from that point, from the center. And that's why we're going to use the distance formula, because by definition, every point on a circle should be equidistant from that center point. And we just talked about a second ago, what is the distance called from the center to the edge? Well, that distance is called a radius. That's what I'm looking for here. So basically, we're going to write the distance formula for the radius of any circle. And that's why I'm using weird variables here. I don't think most of you have seen this. This is h comma k. Those are the kind of the mx plus b versions, the m and the b, so to speak, for a circle equation. H and k represent the center of the circle. H is the x-coordinate, y is the k-coordinate. You will see this a lot in Algebra 2. You'll see this with circles in Algebra 2. You actually see it with parabolas in Algebra 2. You see it with the ellipses or ovals in Algebra 2. It's a very common set of variables. Why is it h and k? Don't ask Mr. Hess. He doesn't know. There's probably some really good Latin reason or Greek reason or some other language reason on there. But h, k are the letters they use for that, which is what this, these fill in the blanks on your paper. The center of a circle is usually called h comma k. Why is it h, k? Well, I don't know. Why not? The second thing I want you to pick, and I don't care where you pick any point along the edge of the circle. Any one you want. So I just randomly chose one that's above and to the right. And I called it xy because it's a random point. It could have been the one directly horizontal to the center. Any point you want. And I'm picking x and y because, again, it's some arbitrary point on there. We're going to find this distance now. And, of course, that distance is called r, using the distance formula. So think about, it's been, for some of you, this might have been a few days over the weekend. How do you find distance? Well, you find distance by subtracting the coordinates. Finding the rise and the run comes from subtracting the coordinates and then squaring them. So that's what I'm going to go for here. Filling into my blanks here. I'm going to find this distance, this radius, length, by going from the center to some other point. Going from hk to some random point on there. So I'm going to throw in my distance formula. I've got a big square root. I'm going to subtract x and h. That's like finding the run on here. To find my rise, I would have to subtract y and k. And you might have this switched on your paper. Usually they're written in this order. It doesn't really matter. If you switched around, it would still be the same. It'd still be okay. Just a different version of it. And of course, this distance that I'm finding, this is the distance formula, is the radius of the circle. So I'm going to set that equal to r. Now, this right here, we'd be done here sometimes. If you look at the previous problem I gave you, and I'm going to fly back to it, I asked you a few minutes ago, what's the radius of this circle? And most of you figured out it was 5. if you look at the equation that I originally gave you, the 5 is in that equation. Where do you see the 5? And then for most of you, there's like an aha moment. Oh, the 5 is right here. It's the 25 squared. So if you really start to get the hang of circles, flip the page over for a minute. Go to the back of your page, the top of it, and you'll see a bunch of equations on there. Like the first one I've gave you, the radius of that circle is the square root of 10, which is a square root of 100, which is 10. The radius on the second one is 81. So when they're in this convenient form, the radius is always squared on this right side, which means I'm going to go back to what we were just doing a minute ago. We were deriving this equation. We don't want the square root sign on there. Some people hate radicals. We'll get rid of it. Square both sides of the equation, and you get something like this. R squared, this is how I got the 25 before, is equal to these two differences over here, where H and K represent the center of the circle. You know, circle that somewhere on your paper. That is the most important piece of information from today. The whole purpose of this lesson is to understand how to write the equation of a circle, how to graph a circle. It all comes from this. This is, there it is, my little y equals mx plus b for a circle. So if I were to ask you, what two things that would you need to be able to graph any circle? Well, you'd have to know how big it is, which is told by the radius, and you'd have to know where the heck to draw it. That's where these two little numbers here come in, the center. So I've got it up here again. I don't care, if you want a different version of it. It's the same thing. It's just this is all one color font. I don't care, it doesn't matter which one you have on there. As long as you know that you need to know the radius, and you need to have the H and K are the coordinates for the center of the circle. That is the one piece of information. You walk out the door, you've got to know it for the test. You've got to know it for the homework. Circle centered at HK has a radius of r. So the two kind of keys are you've got to take the square root of this when you're working on this to find the radius, and then this is a little weird. If the center was like in quadrant 1, if H and K are both positive, they're going to look negative in the equation because there's already a minus in the equation because of the distance formula. If I went down to the negative quadrant, if the circle was down here, these would both show up as positives because, again, there's a negative already in the equation. If you have minus and negative, that means this would actually look positive. So flip the page over. Try these 6 equations out. I'll give you a second. They're in a slightly different order on your paper. Try those out. Good time to pause. See if you can identify the center of each of these circles and the radius. You don't have to graph them. Just where would they be and how big would they be. I'll put that on part 3 here in a minute.